All right, so welcome everybody to to implementation of the FACE reference architecture and system lifecycle implementations. I do want to share something with you real quick here. And if you're unfamiliar with the webinar WebEx screen, basically any of the participants, if you could please keep your video off and your audio muted. We will be taking questions throughout the webinar. So if you have any questions, go ahead and put them into the Q&A panel. You can type them in there and I'll be reading those as we move along. And let's see. Still trying to let people in. And we will have some dedicated time at the end of the webinar to be able to answer some of those questions if we don't get to them during the panelist question, during the panel piece. If you don't see the Q&A button, then you just want to click that ellipsis button to access additional panels. And at the end of the webinar, there'll be a short poll. It's 3 questions, so it'll be really quick. Give me just a second, and we're going to get some more people I need to let in here, and then we'll get right started. All right, great. So welcome to our panelists. Welcome to everybody who's joined us here today. Essentially, we're going to start off with an introduction from each of our panelists, and then we're going to move into some moderated questions and spend most of our time there. Then we'll have some attendee questions. Like I said, if you can throughout the webinar, if you have the opportunity, if you have questions come up, go ahead and pop them into the Q&A section panel in there. And at the end, we have a short poll. So why don't you guys go ahead and get started? Bob, would you like to start and maybe introduce yourself, just your name, the company that you work for, your title, any experience you have with the Open Group FACE, as well as experience you have implementing FACE or working with the FACE technical standard, applying the FACE technical standard.
Okay, my name is Bob Matthews. I'm from L3Harris Technologies. I'm advanced concepts engineer. My background with the consortium goes back to actually pre-2010 with the formation of the consortium itself, working with the Open Group when I was a NavAir employee, a Navy civilian. So I was the consortium chair for the first 5 years of the consortium and have been responsible for implementing multiple reference implementations while I was a government employee. And now as an industry employee, I am the lead for our MOSA implementations in L3Harris, principally working with FACE implementations on Kratos with the Army, and as well as pursuits for Army and Navy.
Gordon? Thank you, Bob.
Yeah, hello everybody. Gordon Hunt here at Skayl, one of the principals here. Been supporting FACE since early 2.0 phase, primarily in the data architecture, but also on the implementation side. Myself and my other partner here at Skayl, Chris Albart, put forth a few papers on, data modeling is hard and just enough data model and on again. So focusing on models not just for conformance, but models for scaling integration and leveraging artifacts across multiple integrations. So the perspective of how do we actually make these things useful and tackle the integration and, more importantly, the acquisition problem of MOSA. So that's a quick background on me. The other thing, I also come at this from an implementer from the contractor and commercial side, but on occasion, I'm also a Navy engineering duty officer, so I sit on the other side of the acquisition table, so to speak. So I see standards and FACE in play from multiple perspectives. Back to you, Sonia.
Thank you, Gordon. How about you, Bill?
Okay. Yeah, I'm Bill Kinahan. I'm a senior fellow with Skayl. I got about 30 plus years of industry experience, the last couple with Skayl. When I started listing it, I was surprised how much FACE experience I've accumulated over the years. I started working with the consortium just about the time 1.0 was published, right before it was published. I'm not sure the date of that. Maybe you can help with that, Bob. But anyway, I've served as chair or vice chair of the DIOG since its inception about 5 years ago, and before that, I was lead of the data model subcommittee for a couple of years during the end of 2.1 and 3.0 standards development. I've got a lot of experience actually working with the standard. I've designed and built modeling tools for versions 2.1 and 3.0 of the standard. I've led the design and implementation of transport services segments for 2.1 in C, C++, and Ada. And similarly, I've led the design and implementation for TSSs for version 3.0 in C++ and Ada. I'm also a key member of Skayl's Sync TSS product development team. Let's see, some experience on the data model side. I was the lead for the OMS FACE system design OFSD effort, Army or Air Force Navy funded effort to look at applying FACE to OMS. And then more recently, I was one of the key contributors to the ongoing SOSA data modeling effort to model the interfaces there. And just a couple other experiences. I was one of the PIs, principal investigators on the Army's JCA demo effort, which looked one of the first looks at building FACE UOPs and reusable verification components to go with that. And been part of multiple demonstration integrations with upwards of 20 UOPs or more. So good amount of experience there.
Yes, indeed. Thank you, Bill. And Stu, can you introduce yourself?
Hi, I'm Stu Frerking. I'm a principal engineer software engineer at Skayl. Been participating in the consortium since about 2011, so about 10 years. I've been a co-lead of the DIOG language subcommittee for about 7 or 8 of those years. In FACE 3.0, I'm the primary author of the query and template languages, specifically those grammars, of course, the query and template constraints, and the platform data model, the IDL bindings. These have been lovingly referred to as QBERT. So for you arcade game aficionados, you might appreciate that. While working with Fort Vanderbilt ISIS, I implemented the data architecture conformance and verification capabilities in the conformance test suite, and are basically now the gold standard for data model conformance. I am one of the principal authors of the FACE technical standards, starting with 2.0 and through 3.1, and as well as the Open Universal Domain Description Language, or UDDL. My experience with the standard is certainly developing the standard itself, but in terms of using the standard, mostly it's been related to data modeling, developing, consulting, reviewing data models. I've designed and implemented various tooling, including many of the UML profiles and plugins that are being well used in the industry. Back to you, Sonia.
Fantastic. Thank you all. So as you can see, we've got a pretty experienced group of panelists here, and I appreciate you all being here. Before we jump in, just a reminder, because I know we did have a few people add in late, a number of people join us a little bit late. So I will be taking questions through the Q&A panel. If you do not see the Q&A panel in your WebEx webinar screen, it should be at the bottom right-hand corner. There should be a Q&A button. If you do not see it, then you'll see the ellipses, the ... Click on that and you should be able to access Q&A and type your questions in there. For the most part, we've got some moderated questions coming up to kind of guide the conversation with the panelists. But if there are questions that come up that are pertinent, we'll go ahead and insert them as we go. Otherwise, we'll have some time at the end to ask your questions specifically. So please think about that as we're going through. So let's go ahead and start off with the first question here. Bill, maybe you can answer this first, given all of the various experiences that you've had. What was the motivation behind the implementation work that you've done? And Bill, I think you're muted.
All right, I'll start again. All right, so there's a number of motivations actually, for the work that I've done. I mean, the first one is kind of obvious, right? There's customer requirements coming down for MOSA, and in particular to use FACE for software systems. I mean, the customer has experience with, they've had functionality that's spanned multiple platforms that they've had to fund independently for each of these platforms because they're custom proprietary implementations. And they're trying to solve that problem by moving forward with MOSA, which is the right approach. And FACE is a key part of that. So going forward, I expect, just about every proposal to have a FACE requirement, and you're not going to be conformant unless you're there. But beyond that, all right, why is it good for, for an organization to take it on? Well, I come from, a company that was a large organization, and our organization and other similarly sized organizations, have a significant amount of software capabilities they've built, over the years. And, it's really in each of our organization's interest to enable the reuse of that software across a product line, okay? If each one is designed independently or built independently, it's really hard to get reused, and program costs go up and testing efforts go up and so on. So, by using the FACE standard, we can make that more consistent. We can improve reuse across different platforms, not have to invent the wheel over and over and over again. So another key benefit from a large organization is flexibility and integration. So, it's great to have the ability to reuse all these different pieces of software, but if you don't have an easy way to put them together, all right, it's a lot harder to mine the gold out of there, if you will. So, FACE, by having the standard data model interfaces and UOPs and the integration model and some of the flexibility that it brings about, it enables an organization to very quickly and easily map out how they want these reusable UOPs connected together, to figure out how they want to deploy it to their platform, and in many cases auto generate the code or the configuration data that's needed to make that happen. And of course, the system is going to change as time goes forward, so this also makes it easy to adapt to things that you find during verification. For instance, if you have too much allocated to one processor or another, okay, you can quickly and easily change that and rebalance your system and come up with something that works the way you want it to. And finally, looking at the whole life cycle, we want to be able to have it so that have our systems evolve easily, okay, with everything being in proprietary platforms, with proprietary interfaces. It's hard to change out components when a newer, better component comes along. It's a lot more effort. We're going to see platforms are likely to see changes in hardware subsystems or new software capabilities released, and they want to bring them into their system. Or maybe it's not something external, but internal, where they've got obsolescence issues with their computing platform, right? So FACE and the ability to integrate the way you can with FACE allows an organization to keep up the natural life cycle evolution of their product. And those are some of the key motivations, I think, especially for large organizations. Over.
Great. Thank you, Bill.
Sure.
Rob, you might have a little bit of a different perspective from kind of the integrator's viewpoint. So can you answer that question as well? What the motivation has been behind implementing the FACE technical standard?
Yeah, money, lots and lots of money. Um, so the goal there is really we need to deliver faster. The warfighter, our threats, our adversaries are gaining ground, and so we have to be able to deliver product faster than we ever have in the past. And so all of the technical reasons that Bill mentioned are the how we stay ahead of that curve. And so for us, it's the warfighter is the end customer, and how do we get products so that they maintain an unfair advantage. That's our goal, is to constantly provide the warfighter an unfair advantage. And so the techniques that Bill mentioned are all the ones that I would mention for how, but the motivation is to deliver faster, and that gives us a competitive advantage, and that's where the money comes in. And we want that competitive advantage. We are a product to get to the warfighter and solves that problem. So it is both, the business side and providing our warfighters every advantage we can give them as fast as we can.
Thank you, Bob. How about challenges? Bill, maybe you can speak to what some of the most significant, sticking points basically have been during implementation.
Okay. One thing I'd like to start off with is that, there's been an evolution of the standard moving forward, right? We had, well, let's see, 1.0, 2.0, 2.1 was a significant bump over 2.0. And then I have to say that version 3 of the standard really is, in my mind represents, the first big go forward step. I mean, you can do some things with 2.1, but 3.0 solves a lot of the problems that were there with 2.1, like, support for multiple units of portability. It adds the ability to switch out transport protocols underneath, solve some of the problems with IOSS. So, I do want to say that 3.0, is a tremendous move forward from 2.1 and solves many of the problems that were there. Now that we've cleared the big things out of the way, there are still a few, rough edges. In some of our implementation work with TSS, we found that, again, there are some ambiguities that aren't immediately apparent. Okay, you might, go down an implementation thinking that you completely understand how this is going to be used and you've thought of everything. And then somebody comes along and says, well, what about, if somebody uses it this way? And, honestly, I'm like, well, why would they do that? And then I'm like, well, yeah, that makes sense. I hadn't thought of it that way. And, it turns out there are a few of these places where there are opportunities for incompatibilities and so forth. Now, I think that's kind of natural in that, any standard as it's evolving, you're going to find, minor cracks and crevices where that kind of stuff exists. So, again, I think it's part of the natural growth process, but there are still some rough edges. I would like to say that the consortium is doing a good job in trying to address these. There's a number of PRs and CRs that have been written identifying the problems, and the working groups and the subcommittees are working pretty hard to address those issues. When they're addressed, approved corrections are put forward so that that organizations can move forward those approved corrections in their conformance process. And, when there's a significant enough number of the approved corrections together, core agenda are put forward. For instance, 3.1 is a collection of these approved corrections that were put into a core agenda to address some of the issues with 3.0. So, I think we're going to continue to see some evolution as people start digging in a lot more detail than ever before. It's not, it's a natural thing that's going to happen, but it's not going to be bump free. The other thing I wanted to, talk about is I think some folks are still having some challenges, with the data modeling aspect. Okay. To be honest, doing the data modeling does require a significant mental shift for most engineers that have been around for a little while. I think we're used to looking at these kind of interfaces as data structures, right? Where we're sort of tuned in to how do I design this data structure to effectively communicate the information with just a little bit of space and quick access times and those kinds of things. And certainly that's one of the things that you end up with data modeling. But before you get there, you're trying to actually uncover the ubiquitous language of your domain, right? What are the entities and the relationships between those things and the properties of the entities and those relationships, so that you can capture the meaning behind the data before you package it into data structures. And I think that's a mental shift that some people are having, a bit of a hard time with. I'll be honest with you, I've had difficulties with that moving forward too. Every now and then I'll go back and look at some stuff I had done in the past, and my thinking's is constantly evolving on it. And, I'll question why I did things a certain way before, because, I've gotten a little bit smarter about it and my thinking has evolved. And I think that's one of the challenges folks are having right now. The other thing is, it takes some effort to build a data model, and, it's not clear to everybody where the break even is on the one-offs. For instance, if I'm just building one UOP, it seems like there's a lot of work there to build the data model for just that. But I think really we need to think bigger, and the domain-specific data models, which actually capture all this information for a whole community of interest, are really the thing that's going to enable us to get high productivity, to be able to look at interfaces in a more easily comparable way. So those are what I think are the sort of the big challenges right now.
Thank you, Bill. We actually have a question from one of the participants. They were asking, because I think you were talking about the various versions. After version 3.1, version 3.2, and or 4.0, basically, I guess, when are they planned? When are the next versions planned for?
I don't know that there is a specific timeline for 4.0 currently. I know 3.1 has just gone out, so I don't know that there's even a date for a 3.2. Although it probably won't be too far out. I mean, the next year or so is my guess. We'd have to really refer to the consortium to find out what their latest schedule is. But again, I think a 3.2 will go out when there's a significant number of approved corrections that warrants a core agenda. We have right now, I think we're trying to stabilize on the 3.x variant of this and get everything good there before we even start looking ahead to a 4.0. So I think it's gonna be a little while for a 4.0.
Okay, and I know that there were some significant changes between 3.0 and 3.1. Do you expect to see significant changes again between 3.1 and 3.2?
Well, actually, the changes between 3.0 and 3.1 weren't really that significant. There was a inclusion of a number of core agenda, which by their nature, they can't really change the requirements. They can provide clarification. So they've been more clear and removed some ambiguities and that kind of thing. The only significant change, and I don't even think it's that significant, is the splitting out of some of the data model to the UDDL standard that Stu mentioned earlier. So the core pieces of that were factored out into another standard to facilitate reuse by other standards bodies who didn't need some of the FACE specific data model aspects like UOPs and that kind of stuff, but still wanted to be able to build data models of their system and have their their specifics for their standards on how to package things up addressed independently. And again, the content, it's the same. It's just part of it was moved into another standard and is referenced by FACE versus being embedded in FACE. Did I answer the question?
I think so. Thank you, Bill. I appreciate it.
Sure.
All right. So Bill just talked to us about some of the challenges and upcoming changes that we can expect with regard to feedback that's provided as more and more folks start to implement the standard. How about rewards? I guess, Stu, actually, if you can start out speaking about what some of the most significant rewards of implementing to the FACE reference architecture would be.
Well, from my perspective, which is largely focused on the data architecture, it certainly brings a new level of rigor to the definition of data. It extends and or expands on, the problems that were associated with what Bill was just talking about. I mean, in terms of data architecture, we're talking about, defining what the data is itself. We look at the standard, we look inside or peek inside and we see things like observables and measurements and various concerns like that. We also see there's a method for the way that we document those things. The data itself is governed and in terms of also how it is used. We have USMs and DSDMs and SDMs. Generally, the data architecture brings rigor. I mean, it breaks with traditional practices in a sense by including those three perspectives: the conceptual, logical, and platform perspectives. It into a cohesive, hyper-connected model, and it's that hyper-connectivity that derives the value of the data architecture and the data modeling that we do. Not only in the fact that it just unambiguously documents data and semantics and the content of the software data interfaces, but we also have, it's leveraged against a shared data model. We get that graph-like traceability of semantics between data models developed in different times and space. The other things we might look at here is that the model-based approach, right, and the mathematical foundations in set theory, entity and relationship models and relational algebras, those things provide scalability of data. Say, for instance, we get machine-based reasoning, analysis, and discovery. In other words, from a discovery standpoint, being able to, we're talking about relationships that are not necessarily explicitly modeled. So we are able to correlate information that's been modeled at different times in space. The modeling that we're doing is based on a standardized meta model as well, which is basically providing things like it's extensible. We get mappings between the FACE modeling languages, the data modeling languages, and other modeling paradigms and data models. Those data models are used and are traceable because we have these mappings to other paradigms like SysML. We also get in machine-based reasoning, analysis, and discovery on the model, on the modeling language itself as compared to other modeling languages. There is, in a sense, meta-aware transformations. We get discovery of symbolic equivalences across modeling paradigms. So for instance, many of the languages cover the same concerns, perhaps being different in aspects or viewpoints. So, the data architecture itself brings a number of significant advantages in scalability to the community.
Thank you, Stu. Bob, how about you from an integrator's perspective? What are some of the greatest rewards and benefits?
Yeah, actually, I'll jump on the wagon there with Stu on the data architecture piece of it, in that a lot of those technical advantages, what they allow me to do is, if I embrace a model-based approach to my system design as well as my data architecture, I'm not limited to the FACE standard. So I can take my same models and my same data model and my functional behavioral models and my data model, and I can actually auto-generate an OMS cal. I can generate things that put out a specific 4586 message set to any particular user. And so my message model, my over-the-wire instance, can be auto-generated in many cases. So what the FACE data architecture and standard allows me to do from an integrator's perspective is be able to meet multiple customer standards, whether they're using the FACE standard or not. So that is my core, baseline for how I am developing my architecture, is using the FACE technical standard and data architecture to make sure that I can meet multiple customers' needs with one product. That product is model based, and then auto-generated to the needs of a particular customer based on their particular message structure or instance for that. So the ability to use the same product over and over, increasing my reuse, regardless of whether the end customer is using the FACE technical standard or not. That's the biggest advantage to me. Over.
Thanks, Bob. And Bill, do you have any specific benefits perhaps related to the implementation of the transport service?
Well, I'd like to, I guess, talk about two things. I can talk about the transport service, and then I'd also like to, I guess, foot stomp, what Bob's talking about from the auto generation perspective. I mean, regarding the TSS, the organization of the standard and the fact that even within the TSS, there's layers there, allow for a lot of flexibility in terms of implementation. So I could choose to have, on one hand, a fairly monolithic implementation where I've got my type specific APIs, and then, then beneath that, it's just, one giant, transport service segment. Or I can choose to layer it further where I've got type specific on top of an abstract, which is, again, somewhat monolithic. Or I can go down one level below and, have these reusable layers on top of transport protocol modules, which allow me to, pick and choose what kind of protocols I want to use for moving data around. And I'll say from an integrator's perspective, being able to choose from a collection of TPMs that I've got integrated and configured, that I've got configured into my system is really powerful, because I can choose, a transport protocol module. Let's just say I've got two UOPs that are in the same main program. Well, I'll choose something very lightweight, maybe just like a shared memory kind of transport, because they're in the same process with one another, versus things that are on a different machine, across the network. I'll use some kind of network-based approach. Maybe I want to use DDS or UDP, but my point is that the layered and modular approach, of the TSS implementation, allows me to pick and choose and to really, build what's right for my system and how I happen to have it deployed on this platform. If I go to a different platform and I deploy the same stuff differently, I can choose different protocols there. So again, I think that layered approach, really provides, a significant benefit, for implementers. One other thing I'll mention too is that just by the way that it's constructed, you naturally get independence from your hosted platforms and from the languages of the UOPs. Some of the work that I've done, I mentioned before, we've had some UOPs built in C++ and others in Ada, others in C. And, I think, the fact that the TSS insulates everybody from that by, through its serialization mechanism and so forth, you've naturally got this kind of portability, and you don't have to worry about the language differences on how Ada is going to represent information from C++, or how a Intel machine, would represent data differently than a Power architecture. It's automatically taken care of for you. So I think that's, again, something, we've had to worry about in the past, with bit and byte oriented, message mappings, and that's completely gone now with the use of the TSS. And then I mentioned, I wanted to really jump on to, what Bob was saying about auto generation. I mean, I'm constantly amazed at how much, a smart organization can leverage, the models here. So you've got models that describe the types that go in and out of UOPs. You've got the UOPs themselves and their interfaces. You've got the integration model, right? From all of these, you can generate all the data types, all right, which is actually a significant amount of code. You can generate all the APIs for the type-specific side of the TSS, not a trivial amount of code either. All the serialization and deserialization code required to, package those up to move across your transport, all automatically generated. The configuration data that says what transport you're going to use and how things are going to be routed from UOP A to UOP B, all that configuration data can be generated out of the tools. You can generate testing stubs, out of the tools, front ends for UOPs that, are ready to populate with code to move the data around. And finally, something we don't really think about, but you can actually generate some instrumentation support out of this as well. I mean, imagine you want to look at your data going across, the Ethernet. Well, you could, if you choose to, generate some Wireshark dissectors to actually, present to pick up on those messages as they go across the Ethernet and present them in engineering units. So it makes it a lot easier to integrate your system from an instrumentation perspective. See how excited I'm getting? But anyway, those are some of the big benefits, from my perspective.
Thanks, Bill. All right, I just want to remind everyone that we have had a few people continue to join in a little bit late, but just a reminder to, if you have any questions, use that Q&A button down in the bottom right-hand corner or click the ellipsis to get to the Q&A, and then you can type questions right into that Q&A section. So our next question for panelists is is to Gordon Hunt. And Gordon, we have in the title of our webinar that we're going to be also talking about how FACE implementation affects the systems development lifecycle. So how does a FACE implementation, or how can it be expected to affect, design, development, testing, maintenance, et cetera?
Absolutely. So can you put up the one picture I sent you, the slide deck, because I want to terrify everybody for a minute.
Sure, will.
And when we start talking about system development lifecycle and lifecycle maintenance of complex system architecture, everybody in the acquisition space, and Bob, you've probably seen this many times, the horse blanket of the acquisition process, all the way from concept of operations to decommissioning on the right, and everything that happens in the middle. And we're not going to go into this in gory detail, but again, part of the question, I started thinking about this, is when and how and should a FACE requirement or a FACE aligned approach, or when do you do data modeling to achieve the architectural benefits that both Stu and Bill and Bob have already talked about? So, do you have to get it all the way on the left, and then flow it all the way to the right? So just wanted to talk about that a little bit. But yeah, when you talk about software development or system development lifespan, this is the picture that comes to mind. And so now the question is, when and how do you levy or take advantage of the architectural benefits of FACE, not the technical benefits? The Bob, Bill, and Stu talked about those. So next picture, I just wanted to kind of put a couple terms out there, because I'm going to, next slide, please. So I'm going to talk to kind of the terms that I'm going to use and try to separate a systems design that's been deployed with FACE UOPs, leveraging FACE TSs, one or multiple, leveraging TPMs that Bill's talked about, deployed on one or more operating systems, on hardware bound to I/O. And so, that's all the way on the left, the actual implementation of the system stitched together, optimized in ways that Bill's talked about. Either it's, a large application hosting multiple UOPs, or I've chosen to replicate the same UOP 8 times for redundancy or fault tolerance concerns. So again, design on the left. And then in the middle, what is kind of depicted there are some of the different architectural considerations. So again, we start thinking about where and how does FACE align. Folks immediately say, well, it's a software architecture and it specifies the implementation of your applications. So FACE, interestingly enough, is a reference architecture, not an implementation architecture, and it leaves a fair amount of intentional variation flexibility in place. And there's an interesting interplay between the hardware, software, functional, and data architectures. And what you see, actually, interestingly enough, going on across many DoD organizations, in the Army and the ACWIG, and the Army, most of transformations, and in the Navy's DevOps and DevSecOps initiatives, and product line initiatives, both on the commercial side and the government side, is this elaboration effectively of your reference architecture to your objective architecture to your system architecture to inform a design. Now, again, those levels are often or sometimes called slightly different things, but at the end of the day, what's really going on is requirements elaboration and trying to get down to a nuanced approach of where and how and when one specifies interfaces between these categories of architectures and the things that implement the capabilities that we're trying to deploy. And so the question really is, when do you actually have to levy a FACE requirement? So again, in the Army, it's levied, and you can levy it at different levels of the organization. Interestingly enough, you can have all the way at the PEO level a FACE requirement, and then in different programs, again, what optional APIs are required, where do I want to place in a UOP, what functional categories. Again, those are things that can be elaborated through that development phase. So again, FACE isn't, this is the way you build it, and it all looks exactly this way, and you have 47 processors connected on these 12 data backbones. Right. So again, from a high level, you can then elaborate where and how your functional architecture to deploy, where you want to put boundaries between the various pieces, parts of your system, and then leave, actually, Bill talked about this a little bit, architectural integration flexibility later through use of the TS to change maybe where and how one optimizes, where that software runs, how many copies of that software actually are employed or deployed across your system. So again, just like I'm elaborating my operational requirements. Next slide, please. Number 3 there. And if you've been in a variety of the Army meetings, folks have seen this image, but on the left are the levels of architecture that I've talked about briefly. And on the right is your standard operational and performance capability-based requirements elaboration. And so again, when you talk about where and how one levies or leverages FACE, it's at what point do I need to make decisions about deployment concerns or interface implementation concerns, or what TPMs I use to achieve a certain architectural effect in support of my operational and my performance requirements on the right. And so again, the FACE reference architecture does afford a lot of flexibility. And this is, I think, both good and bad. Bill talked and Stu talked about the difficulties of the data model. I think even from the software architecture point of view, folks read it and then say, well, wait a minute, I don't know how to implement it, or the implementation isn't fully detailed. It's not a design, and that's by design, actually. So the idea here is when you say, all right, I have a functional capability and I want to make that a UOP. Well, where it gets interesting is that one or multiple UOPs that comprises that functional capability. FACE does not say you have to have one function per one UOP. I could bundle multiple functional architecture specifications into a single UOP, or distribute them across my entire distributed system, fit for purpose to support those performance and those operational requirements. And that flexibility is a really good thing, but it does lend itself to some head scratching sometimes. So in terms of the acquisition process and when one levies FACE, I think the answer to your question is it's a scale, right? There isn't any one moment in time when one has to say you have to levy FACE by now or you're never going to get it, because it's an elaboration process, and you can take legacy software and capabilities and enable their integration through FACE constructs. You can leave them alone and interact with them through their legacy APIs and present that data captured in the data model to the rest of your system, which has been aligned with a FACE reference architecture. And when you do that, again, it kind of depends when it's right for the program, when you have to achieve certain performance or capability-based requirements. And so to me, it gets pretty exciting. So, Bill gets excited about a lot of the technical aspects and the flexibility it offers. And I get excited about just, the integration and that horse blanket of can you make decisions? And if you make a decision, can you change that decision later, right? Because if I have to say that everything is implemented on this technology stack with these protocols, with this hardware in place, and it's going to be in place for the next 10 years. It's really brittle, really hard to come in with new capability and evolve it. So when I see an architectural specification that enables me to more flexibly move things around and address the reintegration of that without going back and re-architecting and re-implementing everything on the fringes, I get pretty excited about that. So again, I think to answer your question, Sonia, it kind of depends when you levy FACE specifications in your software development process, at what detail, fit for purpose. But at the end of the day, you're going to have a unit of code with TS APIs and other optional API requirements levied on it that's going to be integrated with a configurably or flexibly modifiable TS integration infrastructure that glues it all together. So I'll pause for a minute because I can talk about this for quite a while if I need to.
All right. Thank you, Gordon.
Very well.
That was great. And thanks for providing those diagrams as well. So we're getting to the end of our moderated questions. Just, one final thing. I guess if you had one piece of advice that you could provide to a program looking to implement FACE over the next year or two, what kind of short and sweet advice would you give to them? Bob, I'll ask you first.
Yeah, I'll pick up where Gordon just left off. So my answer to the question of when is today. That's really not the salient question. So I would put out the position to the challenge for customers to ask the question differently. How should we implement FACE? So to me, it doesn't matter when you do it. Today is always the right day. It's always better than tomorrow. But whatever you choose to do, you don't have to do an entire system. You don't have to do an entire box. You don't have to do an entire card. It can be one single application. But whatever you do, make it right. Do it the right way. 99% open is still proprietary. So I say the question is how? Is choose what portions of the system you want to have recomputable. What is your minimum procurable unit, and how many of them do you really want broken out for the life cycle? And put a circle around that and say, I want these to be UOPs, or I want them to exist on a piece of hardware that has a FACE conformant environment as well as host interfaces on the hardware. So the real takeaway is get started immediately, make the requirements difficult. Don't use to the maximum extent practicable ever again. It's a shall statement. And not only is it a shall statement, is you have to prove conformance. And you make it a discriminator. If you have the option of adding into Section L&M of your contract to make MOSA or FACE interfaces a discriminator in any way, that allows me to provide you a differentiated answer because I'm going to give you that right solution for whatever you choose to make conformant today. And so that's my takeaway is stop asking why and start asking how, and make that how a real challenge to industry, because we're ready. We're ready to provide that fully conformant solution. But you've got to make it a challenge that people can't wiggle out of, because people will if you give them that opportunity.
Thank you, Bob. And how about you, Gordon? What would your final piece of advice be?
So kind of, again, piling on Bob here, but the idea that a functional architecture requirement may not be an implementation specification. We saw some confusion in this in some of the capstone implementation. So the flow down of requirements, remember where and when variation is desired and where it's a good thing. So I can still have a FACE defined UOP and the interfaces can be defined, but that does not necessarily mean that those are the messages and the signals that are being exchanged when I come to do integration. So too often, again, it's up-leveling design optimization concerns. That's what I would say. It's like, just be on the lookout for that. Too often, very specific design optimization choices are being pulled all the way up into that reference architecture. And I'm not saying it's a bad thing, but be very, very clear when you do it. And if you need it for functional or operational performance-based concerns or architectural-based concerns, then by all means do it. But have implicit up-leveled reference architecture requirements that then flow back down and say, well, I have to have one UOP per process and one process per partition and two partitions per hardware. You're like, well, wait a minute, where did that all come from? So again, just be very cognizant of and explicit about the details and requirements that are being levied, so you can make sure that you're actually leveling requirements you think you are. Because often when you just say implement this UOP, the UOP becomes a process, the process becomes a hardware node, and then poof, you're done. So again, variation's a really good thing, and so is specificity, but don't leave specificity off the table. That's what I'm saying. I'm not sure I answered your question, Sonia, but I think if I had to distill it to one sentence, it would be interfaces are not messages.
All right.
So again, that's probably what I would simplify it to.
That's a great simplification down to a single sentence. And Bob, if you have a single sentence to represent what you summarized, could you come up with a single sentence?
It doesn't matter what percentage you make conformant, but make whatever you do right. Make it 100% conformant.
Okay. Thank you. So I want to be sure right now we're going to go ahead and take attendee questions. So again, please look for that Q&A button down in the bottom right-hand corner of your screen. If you don't see Q&A, click on the dot. You should be able to get to Q&A. You can type your questions in there. The first question that we have is, how do I deal with a FACE requirement when I'm dealing with legacy software? Anybody want to take that one?
I can talk to it in a little bit. I mean, I think, some of it comes down to what aspect of your legacy system, are you trying to address, right? If you've got a particular function you're trying to move forward, I mean, I've had good luck with, taking the interfaces that are there and building a simple wrapper around it to adapt it to FACE as a first step, right? Maybe you'll follow that up in the future with, something to make it more, more of a native speaker of FACE versus, adding a translator on the outside. But, that's a fairly simple approach. Now, if you're trying to have new FACE components, interact with, existing systems or capabilities, you might have to start out using, IO type interfaces until you can get things, data modeled and a broader percentage of your system, using the FACE transport interfaces, right? Just, you have to look at what it is you want to bring forward, what you're going to interact with, and work that into your strategy. I don't know, again, a lot of it depends on, what legacy pieces you're trying to move forward.
Okay. Thank you, Bill. We have
I'll pile on that too, Sonia. Just
Sure.
Again, so if my legacy device was a protocol-based implementation, taking advantage of some of the 3.0, 3.x capabilities like TPMs, and while not explicitly part of the FACE technical standard, if you capture the data coming off of that protocol TPM interface as a data model data type, then you can leverage some of the other architectural aspects of FACE to figure out where and how that legacy device's information needs to go or should go, form or function. So again, just kind of taking advantage of the tools offered by FACE and applying it to, at the closest extent possible effectively to the legacy device to figure out what the data is and what it means, and then use that documented information to inform your integration.
All right. Thank you, guys. We've got a few more questions. I want to try to squeeze in as many as we can. So what advice would you give to a brand new data modeler coming onto FACE? let's see, Stu, is that something you might be able to answer?
Yeah, I think so. So one of the things that in terms of developing the specification for data itself, the actual exercise of modeling data, we attempted to leverage existing technologies, approaches, standards. I think like SQL, right? So there are some parallels between SQL and what we're doing with FACE. They're both entity relationship models. If you have any experience with SQL or data definition, data manipulation, then that'll help bridge the gap a little bit. In terms of the FACE standard itself, there are first-time modelers will often try to use or mimic, in a sense, the meta model, in a sense, the way that it organizes the information that it expects in the exact same organization. And that's a mistake. I mean, really, all you're really after is to capture the conceptual elements, create views on those things, and map those things to your software components. You don't actually have to go through the full exercise of modeling logical entities and platform entities. Some of those things can actually be generated. So just some thoughts.
Yeah, Sonia, just another elaboration on that. I think again, the maintain perspective on what it is you're trying to do. There is a difference between documenting a data type as presented in a unit of code versus documenting the meaning, form, and so that's one, it's documenting the structure. But two is what do those individual attributes in the interface mean? What other things are they related to? What other interfaces are they related to? That's the second part of the data model. And so I think there's a lot of folks come at data modeling with a very focused top-down kind of thing, right? So I have to get all of my core concepts in place and I elaborate it all the way down, and eventually I get the data types, and then finally I can write some code. And I think the data model development process can actually be much more streamlined and agile in that I know what data needs to be presented to this function for it to do its work, and I can connect it to the forming entity model in parallel effectively. And so there's workflows that are, I think, more efficient rather than a top-down monolithic approach. Over.
And if I could just jump in with one other thing, I'm sorry to prolong this question, but really focus on your conceptual entity model, right? I mean, that's the key thing, the concepts, and try to avoid composition wherever you can. I mean, we're so used to doing data structures where a structure composes a structure to give it context, right? And that's how I started out, and I've learned over time that really, all those kinds of things are different associations where, what I find is if I'm going to put a qualifier in front of some piece of data, right, there's a hint that you've got an association there. For instance, current waypoint or next waypoint or those, starting waypoint. Those are all qualifiers, on waypoint, and that's the role that a certain waypoint is playing. That doesn't mean it's composed into my flight plan. There's just a relationship between the flight plan and some waypoint. In one case, it's the current waypoint. In another case, it might be the next waypoint. But those kinds of things, all these relationships whose names have adjectives out in front, need to be captured as associations versus, entities are composed in things, or role names as when they're composed in. So just be careful. I mean, if you're not building a model that's 60 to 70% associations over entities, you're probably not teasing out the right level of detail.
And I will add on to that I know we at Skayl have written a number of white papers about data modeling to the FACE standard, technical standard. So you can go on Skayl.com and look under resources, white papers, if you want to be able to read those. In fact, hopefully we've got one coming up that is exactly in fact, talks specifically about patterns, and one of which Bill just mentioned.
Yeah.
We've got no time left here. We are having some participants who I think are needing to drop off. Can somebody answer real quickly when a UOP, probably not, but we'll try. When a UOP is certified for a given version of FACE and you get a request to integrate it with components certified for another FACE version, you have to upgrade it, or can you integrate these components?
You should be able to integrate them.
Okay, great. Thank you. And if any of you attendees have additional questions, feel free to email. You can email me, Sonia, SONYA @skayl.com, or you can go onto the website and you can, skayl.com, SKAYL.com, and you can complete a doc there, like a quick contact form, and ask any additional questions. I am going to put up a poll real quick here. And also we'll mention that in June, we are going to have a webinar, not a part of this webinar series, but we're going to provide a demo webinar of Phenom, which is our collaborative data modeling tool, which was built in order to rapidly align data models and to the FACE technical standard, and also generates a configurable TS, FACE TS. So that is going to be in June. The date on that, I think, is, you know what? Well, you guys will be receiving something. Just keep an eye out for it. And right now, I'm going to go ahead and I'm going to post a poll. It's real quick, 3 questions. You want to go ahead and answer those questions for us. We greatly appreciate your engagement today. You guys had some great questions, and thank you very much to the panelists. I think this was a great subject. Obviously, we had a lot of people who are very interested in it and find it very applicable. This video has been recorded and will be shared as well with the participants. I'll be sending out a link to that. So, hopefully that will also provide an additional resource for you. As mentioned previously, there are additional resources also available at Skayl.com. There are white papers available there. We also have some various different articles, and you can sign up for a free demo of Phenom if you'd like to see that as well. So feel free to go on there. Do you guys have any parting words, any of the panelists?
I'll just say, Gordon, you missed the most important advice to any new data modeler out there. It's send me your resume.
There's that too. All right.
Thanks for that.
Thank you all. I'm going to leave the poll open for a few more moments, but thank you again for attending, everyone.
Have a great day, everybody.
Bye-bye.